Hey everyone, welcome to this session on integrating with AI using Azure Logic Apps. I'm really excited to be presenting to you on this topic. AI is something that is continually moving and changing in our industry, something that's at the forefront of everyone's mind. And so there's a lot of information that we're going to go through in today's presentation, pertaining to different patterns, agentic patterns, and specifically we're going to showcase a lot of various things about Azure Logic Apps, and how we can use these agentic patterns in this tool. So the agenda for today is we're going to start with a quick introduction. So if anybody who doesn't know who I am, I'll go over that there and some goals for today's presentation. Then we're going to level set so everybody's on the same page in terms of terminology and just a quick overview of large language models before we jump into kind of the main content where we'll showcase a lot of demos of autonomous agents. We'll go over the retrieval augmented generation pattern. We'll take a look at human in the loop when we're talking about agentic agents. We'll go over MCP servers and using Logic Apps and MCP server. We'll talk about multi-agent patterns. So we have instead of one single agent, we'll have many agents and the patterns and some demos around that. And we'll have some time for questions at the end. And we'll finish off with a few final thoughts from myself. So my name is Cameron Mackay. I am an Azure integration MVP with Microsoft. I've been in the industry for about 12 years. And over that time, I've worked on a lot of different technologies, mostly in the Microsoft sphere. Started out as a web developer, working on the Microsoft stack, building web forms applications. Moved into cloud native web app development in Azure. And over the past 5 years, I've been building integrations in Microsoft Azure. So if anybody wants to chat about integrations over the next, or wants to stop me afterwards or chat with me on LinkedIn about integrations, feel free to send me a message. Happy to chat about those. Really excited about integrations overall and Microsoft's approach to them. So happy to chat about those. And I also wanted to call out that I'm a huge proponent of security and defensive programming as part of the SDLC. So that's something that I always have at the forefront of mind when working on these solutions, and I feel is very important in our industry. So if you could take anything out of this presentation, there's two things that I would like you to get out of it. The first is that if you have a lot of different SaaS platforms in your current IT infrastructure, then you can use a tool like Azure Logic Apps to gather information and gather data and connect those systems to your agentic AI or your AI workflows. The second is that if you chose to, if you wanted to, you could take the information from this presentation and spin up a Logic Apps instance in the portal, or you could open up VS Code and install the Azure Logic Apps extension and build an agentic workflow right after this. The barrier to entry is very small. The Logic Apps team has done a fantastic job of creating labs if you want to get further and deeper into it. So there's a lot of information, a lot of things that you can leverage to build in this space. So with that, let's take 15 seconds on your own to think about, what do these words have in common? So the main thing that we're thinking about when we look at these words is that they all connect, to places together, or they're all taking, maybe some kind of material and connecting them together. But the key here is that we're actually connecting things together that would not normally have been connected. And this is really important when we're talking about large language models or agents, in that their power really comes from the ability to connect to various systems. And so we have a lot of different choices in the AI space. There's a ton of different things out there, and really the power of all of these comes when they're able to talk to other systems, able to retrieve data or perform functions in other systems. On their own, they do have a lot of utility, but the real power of them comes when they're able to connect to other systems. So let's talk about large language models. So there's a ton of commercial large language models available, and you can see a lot of them on this slide here. The key with these is that when they become commercially available out of the box, they're trained on finite sets of data. So whatever that data set is they were trained on, that's what they know, that's what they're able to provide information on. And the other key piece to know is that large language models are not a database lookup. They're not there to perform queries for you based on information. What they're actually doing behind the scenes is they're doing pattern matching. So they take your prompts, they break it down to tokens, embeddings, and then they use that information to find similar things in their database. So it's kind of like a lookup, but it's not the same as a traditional lookup. And so really what it's doing is matching based on text. That's why you have to be very specific about how you craft your prompts to get the output that you're looking for. So when we talk about AI and agents, we have to talk about agentic and non-agentic workflows. So when we talk about non-agentic, we're talking about programs where the human or the person developer is in charge of the control flow of that program. So this is traditional development. We might make use of an LLM at some point to perform some kind of processing, but ultimately the human is at the center here, and we're in charge of all the business logic, the whole control flow of where the execution goes, all those if statements and looping constructs. So here's an example of that kind of traditional flow where you might have a prompt come in, we run some code, maybe we call into an LLM, and then we take that output, we massage it and do what we need to. But the key here is that we're in charge of the flow of this program. So when we move into agentic workflows, what we're talking about is moving away from that traditional developer-driven flow, and instead we're going to now allow the large language model to make a plan, act on that plan, and then iterate over that plan. So we're no longer the ones in control of how that plan gets run. Instead, the flow of our program is driven by the agent itself. So the agent will make those choices. And so here's kind of a example of that where the agent's going to use your system instructions, your prompt that you're providing initially. It's going to use that to create a plan, figure out what to do. It's going to do some kind of actions, maybe get more information or perform some actions in various systems. And then it's going to basically act on that plan and do what it needs to do. So when we're walking through this flow, what's really important is that, going back to the large language models are powerful, but they're more powerful when they have access to information and when they have access to functionality. And so we can do that through tools. Tools allow the agent to get more context, so more information about what they're looking to do, or to answer the prompt, or get more matching information for your prompts. Be more specific about the responses, and then they can also do functionality based on and act on things over here using those tools. So this is where the power of agents really comes in, is when we have good tools to back it up. And so here's kind of the agentic workflow, and we have those tools available to us. The LLM is still going to go through that acting, processing, planning state, and then we're going to have those tools underneath so that it can actually perform various things for us. So with that said, this new agentic workflow creates two problems, and they're problems that a lot of IT organizations have. The first being that if our agentic workflows are only useful or their true power is unlocked when we have data available for them and functionality available for them, how do we get that data to be available? We have APIs internally. Usually, a lot of organizations don't have this, and so we need a way of getting that data to be accessible to our agentic workflows. And the second is, how do we make sure that the stuff that is available to our AI is secured and we're not doing anything that we shouldn't be doing by exposing it through our agent? So the key here is that not all data is readily available in organizations. Some have APIs, but if you don't have them, it's going to take a long time to build them. And then not all functionality is exposed through those systems. So if you don't have it out of the box, well, are you going to build APIs, or what are you going to do to make that available to your agent so that you can truly leverage the power of agentic workflows? So that said, what if you, as an organization, as a developer, as an architect, could take out-of-the-box connectors and use them to expose the data from your existing SaaS systems so that it can be integrated with AI? What if you could make AI development so easy and so straightforward to integrate your systems with AI? So all that functionality that those systems provides are now exposed and available to your agentic workflows. And what if you could maintain an enterprise level of security and scaling with tools that you're using to integrate and build those AI solutions? So you get all the functionality from your SaaS systems, all the data from your SaaS systems, and all the security from your SaaS systems. Sounds too good to be true, right? Well, we can do all of those things with Azure Logic Apps. Okay, so Azure Logic Apps is our tool of choice, and with that tool, we get a number of connectors that are available to us. And so you can see just a high level diagram here showing Azure Logic Apps at the center. On the right side, we have a ton of different SaaS systems that it can integrate with out of the box. On the bottom, there's a ton of different data sources that it can integrate out of the box with. And on the left side, we have a bunch of Azure data sources or resources that it can integrate with out of the box. And then at the top, really exciting, we have a ton of Azure AI-based resources that Logic Apps can integrate with. So you have cognitive services, you have OpenAI, you have AI Search, and AI Foundry. All these items are critical and extremely powerful for us to build agentic workflows with Logic Apps. And just quickly, there's two kinds of Logic Apps. There's consumption and standard. If we're going to build agentic workflows, we're going to deal with standard only workflows. And the big reason we go for that, there's a lot of reasons. Here's a few of them. VNet integration, security, really important. Predictable pricing is nice. We can do low code, pro code together, which is really great as well. And then finally, if we want to build agentic workflows, we're going to use Logic App Standard. So here's our typical infrastructure for a Logic App. You're going to have Logic Apps at the center, Key Vault for secrets, storage container that's going to have your code in it, and all the different executions, app service plan for your compute, dedicated compute, and then app insights for logging. So pretty standard things we're used to in Azure. In terms of our development environment, we're going to use GitHub or DevOps for CI/CD. Then we're going to have our Logic Apps. We can program in C# or JavaScript. And now, Python is actually available as well, something that was recently released. We're going to deploy into Microsoft Azure, and we're going to use VS Code or the Azure portal for development. And for the purposes of today's session, we're going to focus on VS Code. Okay, so with that said, let's get to the really exciting stuff, which is integrating with AI in all of our demos and all of our demonstrations. So what everybody is here for. Okay, so let's jump into some examples of integration with AI, and we'll start with autonomous agents. So calling back to what we were talking about previously, in an agentic workflow, we're going to have the large language model at the center, doing the reasoning, acting, iterating. It's going to come up with a plan, and then it's going to act on that plan. And it's going to act on that plan by leveraging tools, perform various actions, and retrieve various data points. So the examples that we have here for demo are a translation agent and a weather agent. Let's jump into that. Here we have a basic agent where we have an endpoint, our basic workflow. It's created as an endpoint, so when you receive an HTTP request, it's going to perform its action, and from here, it's going to execute this agent loop. The agent loop is hooked up to Azure OpenAI, GPT 4.1, and here's our system prompt. This is the prompt for how the agent is going to perform its task. You can see that we want it to respond with hello, how are you, in any language of its choosing. And then it's going to take the output of the agent and respond back to us. So we can execute our hello agent here. And you can see it chose Japanese and responded in Japanese. This time Italian. And this time Swahili. And so we can actually go and take a look at the execution. And we'll see that in this window on the right, this is the system instruction we provided, and it created its plan, and then it output this here. So next, let's take a look at a little bit more complicated example, a complex example, that being a translation agent. And in the translation agent follows similar process, whereas instead of only translating a single phrase, we're now going to tell it to take the text or the prompt that it's receiving, determine the language that we want to translate to, or which language it's in, what we want to translate to, and perform the translation. And so there's quite a bit more to this prompt. And one other thing that's different is, in addition to our system instructions, we also provide a user instruction. So this is the prompt that's being passed in. And so we have a prompt being passed into this HTTP endpoint, and it's JSON, and we're providing that as an instruction as well to the model. So in addition to our system instructions, this time we also have user instructions. So we can use this, and we can say translate the text hello, how are you, in French. And you can see it figured out the text to translate, what language it was in, and what language you wanted. And then bonjour, comment ça va is how we would translate that into French. So our final example here is a weather agent. And so the weather agent is going to show a bit more complicated prompt as well. This time we're going to take a look at tools. So same as before, we're passing in a prompt. We're asking our weather agent to determine the location that we're asking for somewhere in the world and use that location to determine the weather at that location. And once again, we're passing in the prompt. And we also have this tool now, whereas instead of having the agent figure out the weather, we're going to have it leverage this tool. And from this tool, it's going to get the weather. So in addition to what's going on here, we also have within the tool, what's really important is we have a description. And this tells the LLM or the agent what information or when to call this tool. So whenever it needs to get the current weather for a specific location, it knows to call this tool. We also have agent parameters. So these are parameters that the agent will determine as part of its execution. And so the location. Okay, so here's our weather agent. We have it set up the same as the previous ones, where it's an endpoint that's receiving a prompt as a string. We have a system prompt here, and we're passing in the prompt from the user as an instruction. We're going to have the agent determine the location that's being asked about and then ask for the weather using a tool. So one key difference is we now have a tool, and the important piece with tools is that we need to provide a description here that allows the agent to know when to call this tool. So whenever it needs to get the weather, it's going to call this tool. We also have agent parameters. And so these are parameters that are passed into the tool, and we have a location. So the agent is going to determine what this location parameter should be based on the description that we provide. So we're telling it could be a city, region, state, etc. Various things about what a location could be. And we're also letting it determine what the measurement of unit is. And we're also grounding it by telling it can only be imperial or metric. And so you can see we are connected here to MSN weather. And from there, we're passing in the agent parameters. So whatever the agent determines is location and whatever it determines as the units. So let's call this agent. Okay, so let's ask the agent to tell us the location of the coldest place on Earth. So we can be as specific or as cryptic as we want. And we also asked to give us a riddle, a joke, and a poem. And you can see the coldest place on Earth is Vostok Station, Antarctica. Let's try the hottest place on Earth as well. Okay, and the hottest place on Earth is saying is the Lut Desert in Iran. Interesting. I wasn't able to determine, call the tool to get the weather. Let's take a look and see the execution of this agent to see it running that tool. So you can see here that we have our system prompt being passed in, and we're asking it for the hottest place on Earth. It's calling the weather tool, but it looks like the MSN weather doesn't have information on the weather for this place, so it wasn't able to provide it. You can see a not found being returned back from the API. Okay, so we saw some examples of autonomous agents. We had a translation agent and weather agent, where the weather agent was leveraging tools that were available to it. Saw the power of that. So now, what about context? So if we need to add additional data to these LLMs, since we're leveraging LLMs out of the box, how can we add additional context so that the accuracy of their answers matches information that we want them to use? So let's talk a little bit about retrieval augmented generation. So the typical pattern for RAG starts with a data source, and we're going to talk about document ingestion. So if you have PDFs or Word documents or Excel sheets, all of that would fall under here. How can we make those available to our agentic model, our agentic workflow? So we have a data source, and then we're going to use these new Logic Apps connectors called parse document and chunk data. So the purpose of these two is the parse document will take that data and it'll basically pull out all the information from that PDF, from that Word doc, from that Excel sheet, etc. You don't have to worry about extracting the information. Just leverage this out of the box connector. Same with chunk data. It's going to break up that data into chunks so that it can be used and sent over to our embedding model in Azure OpenAI. The embedding model will convert those over to vectors, and then we're going to use Azure AI Search to store those vectors in an index so that they can go into our vector database, and then it can be leveraged as part of our search. So the infrastructure here in Azure, the way this would work is we have a document, and then we put that document into a storage account, potentially. Logic Apps is going to read that document, go over to Azure OpenAI to call a embedding model to get the embeddings, and then it's going to push those over to Azure AI Search. as into an index, and that will go into its vector database. On the other side, once we have all that stuff indexed for us, we can integrate this into our agentic workflow. We receive a prompt. We're going to go have our logic app go to Azure OpenAI, the embedding model once more, convert that prompt into embeddings or into vectors, and then use Azure AI Search to find matches to that prompt. Then we're going to take the prompt and the vector search results from our specific information, send that over to the large language model, and then we'll get a response back. So the key here is that instead of only sending the prompt to the LLM, we're now sending additional information that we ingested as part of this workflow, and so we have additional context when the LLM actually responds. And it will result in more accurate results because we're giving it the data it needs to answer those questions. And so here is the infrastructure. We have our logic app, which calls into OpenAI to get an embedding from that prompt. And then it's going to perform a vector search using the Azure AI Search connector, search into that database. And then we'll send a request off to our OpenAI LLM to perform processing and get us the response we're looking for. So this is a little fun one where I have a few D&D Dungeons & Dragons character sheets that we're going to use and ingest into a RAG platform, well, into this infrastructure that we're showing here, and we'll do some queries to see how it comes out. Okay, so the first thing we want to do is let's show you an example of. So we have this character sheet here for Bruno or Brunor Frostbeard. So if we go over and make a call to our workflow to retrieve data, we can ask it for the backstory of Brunor Frostbeard. And I had previously ingested Flint Frostbeard, so we might get some information about him. So it says, it looks like you asked about this person, but they found information about Flint, but there's nothing about Brunor. So that makes sense because we haven't ingested this for use. And so if we go into the Azure portal, I'll show you a few different resources and how they're all set up. The first being inside of Azure AI Search, we have our index here, and we can see that nothing's been ingested yet. If we go and take a look at it, the fields that we have are the name of the document, content of the document, and then the embeddings that everybody used for lookup. We also have our container, and so we have a few containers in here. The one that we're going to push the data into is going to be this one here. And then we also have our AI Foundry, and I'll launch that for you here to show you the different models that we have available for us for use. So we're using this embedding model and using this OpenAI GPT-4.1 LLM in Agent Loop. And the final piece of the puzzle is Logic Apps. And so if we go and look at our designer here, it's going to be triggered whenever a blob is entered into that storage account. We're going to read that blob, parse the document, chunk the document, then call this get embeddings, and you can see we're referring to this specific embedding model. Then we're going to take those embeddings and form them into that index, and then give a call out to Azure AI Search to add that index to, or add that document to that index. So pretty straightforward. This all comes out of the box. So if you were to add from template, you can actually do a search for RAG, and you can see there's a ton of different RAG patterns for different data sources. Here's one for Cosmos. Here's one for Azure Files. The one we're using is this one, blob storage, but there's a lot of different ones, and the pattern's pretty similar in all of them. But you can click one of these and configure it, and then off you go. You have RAG set up for your application. Okay, so let's show a demo of this one in action. So let's upload a document, and let's upload Brunor Frostbeard. Upload. Okay, so now that our file's been uploaded, we expect the ingestion of the Logic app to trigger, and we can see that it's running, and it finished in about 2 seconds. If we go into the execution, you can see the output, like reading in this output, it's all base64, so not fairly readable. But you can see the chunking of the data, pulled out all the different metrics for them from that document, or from that character sheet, I should say. Converted that into content and embeddings, and then we took that and all of it went into the embedder. So if we go back into Azure AI Search and do a refresh, you can see that we now have a document ingested. And if we come back into our Logic app and do a search for Brunor, you can see now it's finding information about Brunor. It wasn't able to read the backstory, or maybe I didn't write one for Brunor. It's also very possible. And it gives a sample one. But you can see that it pulled out a lot of information about the characters themselves. So one other thing I will show you in here is the actual agent that's doing the lookup. So like our weather agent, this one is very similar. It has a tool available to it, but instead of calling out to a service, you get the weather. We have our tool here that searches D&D characters. It takes the prompt that was provided to it. It calls out to that Azure OpenAI embedding model, gets back the vectors, and then sends that over to our index and passes through the embeddings. And the model, the LLM itself, GPT-4.1, takes the results of this and uses it as part of its search. So it decides to call this, and it also takes the information from that and uses it. So if we take a look at the actual execution, you can see that as it went through, received its question, and then it called into this search tool, and it made a call to this and leveraged it, and then it came back with this response. Okay, so we just saw a demo of the D&D character agent using RAG. So let's move into some demos using Logic Apps agents, but instead of being autonomous, they're now going to be conversational, and we're going to have approvals or humans as part of the loop. So it's the exact same kind of flow. The difference now is that when the agent calls out certain tools, those tools are going to ask for human intervention, and they're going to require an approval or some kind of input before the agent continues acting on its plan. So we have two examples here. The first is a simple rock, paper, scissors agent, just to showcase how that works. And then the second one is more a common problem that I have in my when I work in integrations, where mappings are often missed or incorrect, and they can even be missed in production before you go to production. And so when you get there with that production data, we're missing something. And so what we need to do is actually fix it. It can take a bit of time to go update those mapping tables or update the code to do those mappings. So why don't we just have an agent as part of that loop test it, and then deploy it. And when a mapping is missing, it's going to fix it. We don't have to worry about it. So let's show a demo of those guys. So the first one with the rock, paper, scissors agent is very simple. And it looks a lot like the autonomous agents. The key difference is that the channel that's being used. So if we click in here, you'll notice this channel here. So before we were leveraging this one or this one for autonomous, where we're only accepting inputs or not accepting any inputs. This option allows us to receive and process, receive input and output. So we can send data in and also receive output from the model. And you can see the prompt here is nothing special, just telling it how to play the game and do its thing. So let's trigger this agent. So let's open up the execution of our rock, paper, scissors agent. And so you can see on the left side here, we have our window and we have our prompt coming in, and it's asking us to pick, rock, paper, scissors. In the prompting, I told it to be a little cheeky with the way it works with us. So let's tell it rock. And I picked rock, and it chose paper. Let's see, maybe it's cheating. I told it not to cheat, to pick the response before it sees our response. Let's try it again. Let's go rock again. And it chose scissors. Okay, so maybe the agent wasn't cheating. But you can see you can kind of continue this loop with it, and it has conversations back and forth in terms of receiving input and processing it. So if we do a quick refresh here, you can see the number of steps that it takes, and its plan changes over time. And the more we converse with it, the longer this chain will be. So the next agent let's look at is the data mapping agent. And so this one is a little bit more complex. So we're actually making a service call, and then we're going to invoke the agent only if there's an error. So here we have a service call to create an account in a system, and we're saying if there's an error, then execute our agent. And so let's give this guy a try. Send in our mapping, or send in our agent call, or some trigger, and we'll take a look at the execution. And you can see our service call failed. And when our service call failed, we have this as our input prompt. And this is the data that was provided as a prompt or as an error code to our data mapping agent. It's doing some analysis of the error, telling us that, yeah, usually it's a 2-letter or 3-letter code. Makes sense. We can do a look. It's doing a lookup using a tool, as you can see here. And now it's asking us for input, saying here's some options of province codes. We know the error was Manitoba. Which one do you want to go with? And we'll choose 1 for Manitoba. So now it took that response, it saved it into the database for the future so that if this comes up, it's going to relevant to the right one. And then it resent the request to create an account, and it was successful. So this is a nice example of an agent in the loop or human in the loop where we don't want maybe we don't want the LLM itself to decide what mapping should be done, but we can at least use the LLM to give us some options for what it should be, and then let us choose which ones it should be, and then have it retry the request, and then proceed. Okay, so we just saw some demos of human in the loop. Now let's move on to MCP. So MCP is a standard that was developed by Anthropic, and the whole idea behind this is that we need the ability for agents to consume tools for them to really get the power that they need. And so MCP allows us to expose tools over the internet or just to various agents. It's basically the way I like to think about it, like from a web development background. We have web APIs that allow different systems to consume our data and perform functionality. MCP and MCP servers are the equivalent of APIs, web APIs. So you can see our traditional flow. On the LLM side, we have an agent that has an MCP client, and that connects over to an MCP server. And now all the tools exist at that MCP server. So we can have an agent running on our local machine, for example, using VS Code, and it can call out to an MCP server, potentially in Azure, and then perform a bunch of operations. So what I'm going to showcase here is just the functionality available now in Logic Apps with API Center, where you can, since Logic Apps have all these connectors that are available to it, we can expose those connectors as tools using API Center and the MCP server functionality. Okay, so let's jump into a demo of Logic Apps as an MCP server. Okay, so we're starting over here at API Center. And within API Center, we have this new MCP preview. And there's quite a few options here that we can select to allow us to expose various services as tools through an MCP server. We're going to look at Logic Apps. And so the key here is that we want to have a Logic app that is brand new, that has no workflows in it. And so we can select this one here. And once we select it, we have these connector option available to us. So we'll click Add, and we'll search for OneDrive. We'll go OneDrive for Business. And so now that we've chosen a connector, we can see all the different actions or functionality that are exposed through this connector. Each one of these will become tools available for us through our MCP server. Click Save, and you can see we have a connection now to OneDrive, and we have all this different functionality available to us. So now we'll click Register. What it's going to do is create a workflow for each of those different functions. It's going to register this as an MCP server and make it available through API Center. So if we run back over to our Logic app, you can see now that we have all these different endpoints that were created for us automatically. These are all items that we can call from our agent through our MCP server. From within API Center, we can click over to Settings and then View API Portal. If we log in, we will have access to our APIs, and from here we can select our API that we want to work with, and we can copy the URL. From there, we can go back into Visual Studio, and so we're going to leverage the chat functionality inside of Visual Studio. And here we're using GPT 4.1. Okay, so now that we have our MCP server set up, we can go in here and we can see that OneDrive is here available as our MCP server. We can also go in here and go add MCP server, choose HTTP, and then it will become available. I have that one set up already. So we're going to send this request in where it's going to look up information about One Piece characters. You can see it's trying to go to the One Piece fandom site to get information. Now it's going to start generating a CSV file, and then it's going to upload that to OneDrive and then give us the link with the information in it. Okay, so we can see that it's created the CSV file using the data as part of its plan. It's now asking us for permission to upload the file to OneDrive. We'll click Allow. And now it's asking us for permission to allow it to call that create share link by path tool. And the key with all this is that it's leveraging API Center and Logic Apps being exposed as an MCP server, so all that functionality is available to us in our agent. So now if we open up our file, you can see that it has all the information about all these characters, and it was all done through our agent inside of VS Code. Okay, so now we're moving into the final demos of this presentation, talking about multi-agent patterns. And so there's three patterns we're going to look at. One is prompt chaining, parallelization, and the routing agent. So we'll start with prompt chaining. So the way I like to think about prompt chaining is traditional development where you have multiple functions. One function takes the output of previous function and uses it as part of its processing. And this is the same thing where we have one function call another function and then take the output of that one, call the next one, and ultimately end up with the result. Same thing with these agents. We call one agent with the prompt, it performs some processing, and the output of that agent gets pushed into the next agent, and so on and so forth until we have our final output. And so if we take a look at what this looks like inside of Visual Studio, we have our endpoint again through HTTP. We have our first agent that takes in the actual prompt information, and from there we have our second agent. These are all sequential, that takes in the output of the extraction agent as input, so it'll do its processing using that. And then we have our final sorting agent that takes in the output of our conversion agent and passes that in and uses it for its own processing, and then we have the response coming out at the end. So when we call this, you can see that we have some output here that performed all of its processing. And if we take a look at the actual execution, you can see that the extraction agent runs first. Then we have the data conversion agent, and it's taking the output of the data extraction agent. And here you can see all of that here. And then finally, the sorting agent has all of the output from the conversion agent available here. And ultimately, that's what gets returned in our response. So that is the prompt chaining pattern. Really nice when you have, if you want to do preconditions and postconditions on each of these. So each of these can be very specialized in how they work. You can have code run before and after to evaluate those preconditions to make sure the data that's getting passed in is correct and that the data coming out is correct, and have kind of quality gates or touch points between each of these. So moving on to the parallelization pattern. This one operates exactly the same as you would if you're thinking about threads in a multi-threaded environment. You can have multiple threads, go off and perform a bunch of execution, and then when they come back, you can use that information and summarize it or leverage it all together. Very similar to the fan-in, fan-out pattern that's used in function apps, where you send a bunch of function app executions to happen, and then you aggregate all the results at the end. So that's what's being shown here. We have a bunch of different agents that perform their own analysis independently, and then we're taking all that information with the impact summary agent and summarizing all of the analysis for everybody and then providing it as a single output. Okay, so we're back in VS Code and you can see what the parallelization agent looks like. So each of these is an independent agent loop, and they've all been added independently, and you can see all these different lines indicate parallelization, so they all execute at the same time. And then we have our aggregation agent that takes the output of each of those agents. You can see all of those here as an array, and then it's going to aggregate that into a single response, which gets returned back. So if we were to call this, you can see that we get back an executive summary with all of the output from all of the agents summarized for us. And if we take a look at the execution, you can see that all of these agents executed at the same time. We got all the output from each of them. And if we click in here, you can see a lot of information being passed into this aggregation agent from each of those analysis agents. So this pattern is really good if you have independent analysis or independent agents that can act on their own, and also so you can run them at the same time. They have no dependencies on each other, and then ultimately you can do something at the end to take all that information and aggregate it together. Okay, moving on to the last pattern, which is the routing agent. And so the routing agent is used when you want to have a bunch of agents with very specific roles, and you want to take a central information source and then push it to the correct role for processing. So in this case, we have an email arriving kind of a help desk or a contact us email box. We have the routing agent receive those, and then it's going to basically read the information and decide which role each of these should take on and whether they would be able to handle that request or not. And then it would take the response from that agent and then pass it back to send the email response back to the client. Okay, so we're back in VS Code, and this is what our routing agent looks like. It's one agent loop with a bunch of tools. And so here we have the email information, the support ticket, and we're asking it to be a routing specialist and push the support ticket to the right specialist to perform their role on it. The key with this is that we need to specify the right description for each of these tools so it knows which agent to call. So in this case, the account security specialist handles logins and passwords. The billing specialist is here for payments, pricing inquiries, and the tech support and product specialists have their own independent roles as well. So whenever you're creating this, you just want to make sure that it's very clear what kind of requests are handled by each agent, and that way the routing agent will know, which one to push the request to. So here we have an email but being overcharged, and they were charged $50 instead of $25. And so this is the inquiry, and you can see we have a response here that was provided back by the agent. Now I would expect this to go to the billing support agent based on this description of payments and pricing. So if we go over here and take a look at the execution, and you can see that the routing agent forwarded this to the billing support agent. And that's where we got our response from. Okay, so we're nearing the end, the last 5 minutes here. So I just wanted to call out that Logic Apps, while extremely powerful, is actually part of a bigger ecosystem, which is Azure Integration Services. So it's just one component of many, and all these things together really make up a strong ecosystem. But certainly the things we showed today from an agentic perspective with Logic Apps is really great. So I'm going to share my LinkedIn and email at the end here if you want to send me some questions. Happy to discuss. I also want to call out some community items here. There's a Logic Apps Aviators community that's available. Anybody can participate on the Azure Integration Services blog. There's a ton of great people that participate in it. Here are some MVPs that provide a ton of great content. Just call out Stephen Thomas specifically on the AI front. He has a ton of videos on his YouTube channel that are worth checking out. I highly recommend checking out everybody here's YouTube channel, but definitely Stephen for AI specific items. And then here's some people on the Logic Apps product team. These are all fantastic people as well, and they all provide a ton of great information. A lot of them have YouTube channels as well. There's also a Logic Apps YouTube channel that you can check out. They all have fantastic videos about AI and about all kinds of things, Logic Apps, so highly recommend checking out their YouTube channels. There's also a monthly Logic Apps community stand-up that's on the Azure Developers YouTube channel, or Azure YouTube channel. Check that one out. There's lots of good information. All the product team is there all the time, can answer questions and discuss. Lots of highlights. We also have Logic Apps Community Day coming up on October 30th. It's a yearly event, celebrates everything Logic Apps. I'm sure there'll be tons of agentic items, things that I showed you. There's also the Nordic Integration Summit coming up October 20th. Check that one out as well. It's also a yearly event in Sweden. If you're in that area, you can go. Definitely a great one to check out. And also, here's some good resources that you can leverage, things that I used when I was developing this. Once again, Stephen and Kent's YouTube channels are great. And then there's a bunch of labs available for Agentic AI with Logic Apps. So I'll just finish with a few stats that Gartner in 2025 that a lot of organizations aren't ready with their data. So you can kind of see the use of Logic Apps and Agentic AI together and how we can make them ready by using those connectors. And then 49% of leaders having trouble demonstrating business value of this. Logic Apps is a really quick way to show that business value. And 40% of enterprises will combine data and governance. Like, this is really important. Security should be something that we're thinking about and integrating into our solutions, and we get all of that with Logic Apps and Azure. So, final thoughts. I hope that out of this presentation that you'll be able to understand that we can use Logic Apps to integrate with all your SaaS systems, all your platforms, and it's super easy to integrate with Agentic AI. And if you so chose to, you could take this information that I provide in the presentation today and start building your own agentic workflows with Logic Apps. So that concludes the presentation. Thank you everybody for who attended, and hope you found something valuable out of this. And once again, if you have questions, feel free to reach out. My email is here, and feel free to connect with me on LinkedIn.